Hey everybody, it's Mr. Cargan. Today we're going to be looking at kind of a side lesson here, but it's still related to what we're going to be doing in the future. Talk about simplifying square roots. Now, when we simplify square roots, we want to remember some of these radical rules. The radical is referring to this symbol here. The radicand is what we're taking the square root of. So remember what we can do with this. If we take the square root of two numbers multiplied together, that's the same as taking the square root of each of them individually. Same thing with fractions. We can take the square root of a fraction, it's the same as taking the square root of each of them individually and still leaving them in fraction form. So a radical is going to consider to be simplified if there is no perfect square factor under the radical and there is no radical in the denominator. Okay, so we're saying that if we can split it up like this, we don't want radicals underneath. And we'll get to how we take care of that in a little bit. So otherwise, never use a calculator to get a decimal approximation for these problems. We're going to be looking for exact radical answers. So what we mean by that is something like this. If I do, let's say, 2 times the square root of 5, that is an exact radical answer. The approximate would be like this. Now, if I plug in my calculator, I get 2 square root of 5 gives me about 4.47. We don't want these answers. We want these answers with this part. Okay? So write the expression in simplified radical form with no decimals. There's like two main ways to do this one. One is to look for perfect squares. So for example, with 45, I see that I can see, oh, that's 9 times 5. 9 is a perfect square. Okay. And then 5 is not, but 9 is. So if I think about it in terms of my properties, the square root of 45 is the same as the square root of 9 times the square root of 5. Since 9 is a perfect square, I could take the square root of 9, and that gives me 3. And then I just leave the square root of 5 like that. That's it. That's as far as I can go. Now, let's say you don't necessarily know what perfect square there is. Like for 80, I don't know off the top of my head which perfect squares go into it. So let me just start with something small, like 2. I could do 2 times 40. All right. Same thing, 40. I'll take that and split it up. So I'll do 2 times 20. Bring these two down like this. That's going to give me, let's go 2 times 10. And then these twos are going to carry down. This 2 carries down, and then 10 splits up into 2 times 5. So this is called all my prime factors. 80 is the same as taking all of these multiplied together. Okay. When I do this, I'm going to look for perfect squares a little differently. Every time there's a pair of values here, like these two and these two, that is going to be the same as one number on the outside. And what I mean by that is this. If I take the square root of 2 times 2, that is going to equal to the square root of 4, which is just 2. So this can just shortcut to 2. So since this is all technically inside the square root like that, that means that I could take the square root of 2 is 2, take the square root of this one is another 2, and then I have radical 5. So I can multiply these back together, and we get 4 radical 5. And that's it. So this process is if you're not quite sure about perfect squares right away, but it's a good way to get through and work through step by step. Square root of 100. Well, that is 10 times 10. So that's just a perfect square. Perfect. Great. Square root of 14. If I split that up, that's 2 times 7. Neither one of those is a perfect square. So I cannot break them down any further. My answer here is just radical, or the square root of 14. 3,150. Big number, right? But let's just take it step by step. First of all, I see that it's divisible by 5. So 3,150 divided by 5. So that's 5 times 630. Now, you know what? 630 is also divisible by 5. So let me do that by 5. So we got 630 divided by 5 gives me 126. 126 is an even number, so let's take that and divide that by 2. So 126 divided by 2 gives me 63. Okay, and then from here, 63, space here, 5 times 5 times 2. Well, I'll do this right away. 63 is 9 times 7, and 9 is 3 times 3. So because of that, I'll do 3 times 3 times 7. Okay, well, then I start looking for my pairs. Here's a pair of 5s and a pair of 3s. So square root of 3,150 is equal to 5 times 3. What's left on the inside of the radical is everything that did not pair up, like the 2 and the 7. So I'm going to leave that as multiplication on the inside. Well, 5 times 3 gives me 15, and then 14 on the inside. And that's it for our simplifying for that case. Okay, simplify these expressions, no decimals. So when I simplify these, first thing I'm going to do is, if this is root 6 times root 21, that's the same as the square root of 6 times 21. Now I can go ahead and multiply those together, but I already know it's going to have to be broken down. I might as well just do this right here. That's 2 times 3. That's 3 times 7. I have a pair of 3's here. And so that means this is going to equal to a 3 multiplied by the 2 and 7 on the inside, which is root 14. Okay, so in the next one, if I'm doing my fractions, remember I can do this as the square root of 4 over the square root of 81. Square root of 4 is a perfect square, and so is the square root of 81. That's it. On the next one, we got square root of 7 over the square root of 16. 16 is a perfect square, so I'll leave it as the square root of 7 over 4. And that's it. The only thing I could do there. When I do these next properties, make sure when you multiply these through, only numbers that are outside the radical can multiply together. So that's 2 times 3 is 6. And then inside the radical can multiply together as well. Oops, let me do that. And that's 5 times 10. Okay. Once again, I'm going to go through and start breaking it down. So 10 is 2 times 5, and then we have a 5 here. So I have a pair of 5's. So that's going to come on the outside. So it's going to be 6, which is already there, multiplied by a single 5 from there, and then the square root of 2, which gives me 30 square root of 2. Okay. Yep, we got a few more. Now, in order to simplify some of our radical expressions, we'll need to use what's called rationalizing the denominator. So for example, with this one, it's the square root of 5 over the square root of 2. I don't like that square root of 2 on the bottom. It's kind of just doesn't look good there. So what we can do is when we rationalize the denominator, we are going to multiply denominator up to a perfect square. Okay? Yeah, I guess I can write the whole word denominator. So we're going to multiply our denominator up to the perfect square. What that means is if I look at 2, the next perfect square would be 4. So if I multiply this by the square root of 2, that will become the square root of 4, my denominator, which becomes 2. But with our fractions, whatever I do to the denominator, I also have to do to the numerator. So if I do that there, that's the square root of 5 times 2. I can't break that down, so I'm going to leave it as the square root of 10. These two are equivalent. If I plug them both in my calculator, they both come out to the same thing. But we want to leave it in this format right here, where it's the square root of 10 over 2. Here, the same thing, square root of 25 over the square root of 3. We're going to multiply by the square root of 3 and the square root of 3. When I do that, this is a perfect square. So that's going to become 5 radical 3. Underneath, you notice, since I'm multiplying the square root of 2 by itself, it just ends up being 2. So I don't necessarily have to write this step down in the middle. I just wanted you to see that in the first case. Because now, if I have square root of 3 times the square root of 3, it just becomes 3. One more thing before we move on. Don't forget, I cannot divide this out. A lot of people want to take 10 and divide it by 2. No. Same thing here. I don't want to take 3 divided by 3. It is just 5 square root of 3 over 3. Okay? So you're going to leave it like this as your final answer. All right? Oh, one more down here. If I take this and I multiply this by a radical 5 and radical 5, so I have 5 radical 5 over 5. This one I can reduce. Glad it came up. All right, so 5 right here and this 5 right here are both outside the radical. So I can only divide or multiply numbers that are both outside the radical, like this. 5 divided by 5 turns into a 1. So my answer here is just square root of 5. All right, last idea today. Yeah, last idea we'll do, two more, I guess. If there are two terms in the denominator, we will have to use what's called conjugates to rationalize the denominator. Conjugates have opposite signs between the two terms. So for example here, 7 plus root 2, my conjugate is 7 minus root 2. Okay. And again, I'm going to do the same thing to my numerator. So I've got to do the same thing to both top and bottom. Down here, or up here, we'll distribute the 3. So it's going to be 21 minus 3 radical 2. Down here, notice this is actually like a plus b times a minus b. Remember what happens with that pattern. It's a squared minus ab plus ab minus b squared. These two cancel each other out, so we're just left with a squared minus b squared. That's our reasoning for doing conjugates. It eliminates that middle term. And so if I do that, I don't have to go through and distribute everything. Just take 7 times 7 is 49. Root 2 times a negative root 2 is a 2. That's a positive and a negative, so it's going to be a minus 2 here. Okay, and then the only other thing I can do is just subtract 49 minus 2. So we've got 21 minus 3 root 2 over 47. And that's it. That look a little better. All right, same thing here. Let's multiply this by the conjugate. Root 3 minus root 2, or root 3 minus 2. So for here, I've got a little bit more complicated in my numerator. So I got 1 times root 3 is root 3. 1 times a negative 2. Root 5 times root 3 is a positive square root of 15. And then we got a minus 2 root 5 here. Then underneath, I've got root 3 times root 3 is 3. Positive 2 and negative 2 is a negative 4. And again, that's my shortcut. I don't do all that. Here, if I look at what can I simplify in the numerator, not really anything. Some people like to put the non-radical numbers in front. So negative 2 plus root 3 plus root 15 minus 2 root 5 all over a negative 1 here. Since I'm technically dividing by a negative 1, I can just go back and just simplify it by changing out all my signs. So positive 2 minus root 3 minus root 15 plus 2 root 5. And that's it. Last ones here. Simplifying these. So the only thing I'm going to do for simplifying is I'm going to focus on my radicals to start here. Okay, so radical 80. I'm going to take a shortcut with that one. That was 16 times 5. So radical of that is equal to 4 radical 5. So what I get here is negative 4 plus or minus 4 square root of 5 all over 2. As I said before, you can only reduce this. This is a plus or minus sign. So technically, these are all part of like the same expression. So if I'm going to simplify this, 4, 4, and 2 are all divisible by 2. I don't care about the 5. All I care about is what's divisible by 2 since they're all outside the radicals. So if I take negative 4 divided by 2 is a negative 2. 4 divided by 2 is a 2. And then I get 2 radical 5. Over here, if I evaluate the square root of 25 as 5, this turns into 5 plus or minus 2 times 5 over 2, which is 5 plus or minus 10 over 2, which I can do in one of two ways. Option 1 is to do 5 plus 10 divided by 2, and then I go through and do 5 minus 10 divided by 2. Actually, no, never mind, not two ways. I could technically take 5 divided by 2 and 10 divided by 2, but that doesn't make sense here in this case. So here we get 5 plus 10 is 15 over 2. Here we get a negative 5 over 2. And that's my two answers here for that simplifying. Okay, so everything, summarize that real quick, is just radical work. We got a few things we can do. We got the main concepts, which is we can multiply two numbers together that are both inside the radical or numbers that are outside the radical, but we can't do outside and inside together. Additionally, if we are dealing with expressions with our radicals, we have to do the conjugates in order to rationalize the denominator. Oh, and I guess if we want to rationalize denominators, we got to make sure we're just getting the radicals out of the denominator then. All right, that's it for today. Take care, everyone.